AI has been identified as a potential means to study the grid faster, to get through these backlogs of the studies. Of course, you can't have AI actually building the transmission. You can't get AI to put the steel in the ground, but you can get AI to help study it in a more effective, more efficient manner to get that steel built sooner.
Hello and welcome from the Nasdaq market site. I'm Jarrett Banks of CorpGov. Joining me today is Jeffrey Jakubiak, a partner at Vinson and Elkins. Jeffrey, welcome to the program.
Thank you. Thanks for having me.
Now, we hear a lot about the energy needs of these AI data centers, but from a regulatory standpoint, what are some of the significant challenges you see in this space?
The biggest challenge is actually getting it hooked up. And there's a lot of regulatory process involved. Studies have to be conducted of the transmission grid to make sure that both the load at the AI center and the generating facilities, if you're building a new one to supply it, can actually hook up to the grid and power can be flown on the grid without it crashing, quite frankly. And these processes take time.
Great. What role do you see for behind-the-meter solutions? Maybe you can break that down for us.
Yeah, so behind-the-meter solutions means a lot of different things. Really, it means siting a generating unit and a load at the same location and supplying power to that load, the data center, for example, before the power hits the grid. Now, the reality is power flows wherever power wants, but the idea is you site them next to each other and you don't need the transmission grid to move it. You don't need the highway of the transmission grid. But different solutions exist for different types of data centers. If you have a data center that needs to be running 24/7, which a lot of them do if you're going to be supplying information to customers, you need this generating system and the transmission system as a backup. So you're still running into these same kind of regulatory hurdles of studying the grid to making sure it doesn't crash in an emergency situation if your behind-the-meter generation goes down. On the other hand, there are other kinds of AI, for example, LLMs, that don't have to run 24/7. They can have outages. And so you can hook those up to a generating facility and not have a backup from the grid. Saves a lot of money. You don't have to build out the grid to support this contingency. And so that's one way to get through some of these regulatory hurdles if you have the kind of data center that can deal with this downtime.
Got it. Now we've seen a surge in demand for these data centers. How can regulatory bodies best support this transition?
Well, the demand, as you mentioned, is humongous. A couple months ago, I was talking about this. The most recent study was saying that in the United States, by 2030, there's going to be additional 30 gigawatts of demand from data. Now, to put that in context, that's 30 nuclear power plants worth of size. Now I'm hearing 50 megawatts by 2030.
Wow.
Now, whether this gets built or not is a different issue, but that's what they're saying the demand is. Now, one of the ways that the utilities or regulators can deal with this is to get in front of the issue. One of the problems that we're facing is that utilities and regulators are reactionary. Understandably, the utilities don't want to spend more money that's necessary. They're public service companies fundamentally. They respond to demand growth. They respond to generation. New generator wants to hook up, new demand wants to hook up, they build out the system to accommodate that. But that takes time, obviously. You only can start when somebody comes to you and says, I want to hook up to your system. The regulators, similarly, have always been responsive. They only will pay utilities for what is needed, for what actually gets built. But the utilities and the regulators both, particularly state regulators, can be prospectively active in this space. They can commit money to building out the grid, a sort of if you build it, they will come, and I assure you they will come. Building out the grid to accommodate this. That will cut down a lot of the time. Of course, you can't anticipate all the needs, but you can anticipate some of them. And in fact, I think it could be used as a mechanism for fostering economic growth. These data centers, while they may not employ a lot of people after they're built, generate massive amounts of tax dollars. And state utility commissions can be promoting the public good by helping to attract these data centers to the service territories by getting in front of the issue, encouraging utilities to build more to attract the data centers.
Right, so it's really about a growth story for the U.S. economy. How do we compare to, let's say, other countries around the world in this area?
Other countries are facing the same problems. Their grids have just not been built out in a manner to expect this. Some of the grids are facing real problems. Germany, for example, has cut back on its nuclear generation, shut down all its coal generation. It's struggling with generation generally, just like the United States is facing, even though only a portion of the coal and nuclear is shut down, but they still continue to shut down. So it's a similar situation around the world, and everybody's struggling with the issue. There haven't been any great solutions found. The best one that I've identified is get in front of the issue, build it, attract the capital, collect the tax dollars.
Great. Now, what impact do you think AI can have on some of these utilities and their ability to streamline their processes?
Well, as I mentioned, one of the issues is the studying of the transmission grid to make sure that when you hook up the new generation or the new AI center, the data centers, that you don't crash the grid, that the transmission lines, which are like the superhighways of the grid, can handle the additional load. Transmission engineers that can do these studies are few and far between. It's a well-known fact that the engineers are retiring in massive numbers, and they're just not a lot to begin with. AI has been identified as a potential means to study the grid faster, to get through these backlogs of the studies. Of course, you can't have AI actually building the transmission. You can't get AI to put the steel in the ground, but you can get AI to help study it in a more effective, more efficient manner to get that steel built sooner.
You talked a little bit about government role here. What sort of incentives should governments consider to attract these data centers, but also ensure grid reliability?
Well, as I mentioned, I think they should be building out the grid and anticipating the data centers in order to attract the data centers. The returns that utilities typically earn are set by the regulators, a return on equity, anywhere between 8-12%, depending on the regulator, depending on the nature of the business. The utilities are competing for capital with other industries, even within their companies. The regulators can help foster this growth by setting good and strong returns on equity that can actually attract the capital to the transmission grid, to the system that will help support these data centers. Again, it's all tied up in money, as most everything is. If you provide the right incentives to build the electric transmission, they will build it.
Okay, if you look at your crystal ball, do you foresee these utilities becoming more like tech companies?
I don't see the utilities becoming more like tech companies, but I do see tech companies becoming more like utilities. One of the basic presets that a lot of people prescribe to in business is if you have a vertical supply chain and you want to secure your vertical supply chain, own it. Don't buy it from somebody else. I think it's only a matter of time until the Alphabets, the Facebooks, and the others of the tech world are actually owning generating facilities. We've seen a lot of partnering between generating facilities and tech companies in recent years. I think it's only a matter of time until they build their own generating units or buy generating companies. There have been discussions in the business for about 10 years that the Microsofts, the Metas of the world, and even those companies in particular, have been going around buying up brownfield generating sites where coal plants used to be sited, where nuclear plants used to be sited, with the idea of putting in their own power plants, particularly small modular nuclear reactors. These are great sites. They have the transmission capability, obviously. They're brownfield sites, so you have less environmental issues, and they have cooling water, which is a critical factor in running a power plant. I think it's only a matter of time until the SMR technology matures to commercial viability. They start putting in these SMRs, and the tech companies of the world start doing it themselves.
All right, we'll leave it there. It's a fascinating story that's only going to become more relevant. This has been Jeffrey Jakubiak, a partner at Vinson and Elkins. I'm Jarrett Banks, signing off from the Nasdaq market site.